Next we have the examples of balancing a redox reaction by using half reaction method. So before we do the examples, revise once again what are the rules or what are the steps for balancing a redox reaction by using half reaction method. And that rules or the steps you can understand only when we do the exercise question. So the first example, so an ionic equation is given. In 11th and 12th standard we need to write only ionic equations. So that is required for board exam. So here an ionic equation is given which is not balanced. So this is an ionic redox reaction which we have to balance using half reaction method. And here the medium is specified as, this reaction is taking place in acid medium. Now we know the first step to balance a redox reaction is split this redox reaction into two half reactions. That means oxidation half reaction and reduction half reaction. But how we can split this into oxidation half reaction and reduction half reaction? Before that we have to identify which species is undergoing oxidation and which is undergoing reduction, isn't it? And that we can understand only when we assign the oxidation state. So once again I am going to write this equation. The given equation is Cr2O7 minus plus Fe2 plus giving Cr3 plus Fe3 plus. This is the equation given. Now medium is acidic. So first step is we have to assign the oxidation state of each and every atom present. Cr2O7 2 minus. We know that this 2 minus is not actually the charge of oxygen. That is the overall charge, isn't it? Oxygen we know it is minus 2, isn't it? Sum should be, the overall charge or the sum should be minus 2. So chromium we can take it as X. So X into 2 plus minus 2 into 7 must be equal to minus 2. So 2x minus 14 equal to minus 2. So 2x equal to minus 2 plus 14. So 2x equal to 12, x equal to plus 6. So what is the oxidation state of chromium? We are getting it as, here it is plus 6. Now iron, here it is given as Fe2 plus. Chromium Cr3 plus and iron also Fe3 plus. Now after assigning the oxidation state, it is very easy to find out who is undergoing oxidation and who is undergoing reduction, isn't it? Now see the oxidation state of chromium. What is the change in oxidation state of chromium here? Plus 6 changes to plus 3. Plus 6 changes to plus 3 means there is a decrease in oxidation number. And here, now when we write the decrease by how much and increase by how much. Plus 6 changes to plus 3 or plus 6 is reduced to plus 3 means there is a decrease by 3, isn't it? So there is a decrease in oxidation number by 3, isn't it? So it is reduction. Now see the case of oxygen. There is no on the left hand side it is minus 2, right hand side there is no oxygen to compare. See the case of iron. Yes, here it is Fe2 plus, it changes to Fe3 plus. That means increase in oxidation number by plus 2 becomes plus 3 means by 1, and this is representing oxidation. Now we got who is undergoing reduction and who is undergoing oxidation. Now we can split this reaction into two half reactions. One is reduction half reaction and oxidation half reaction. Here, who's undergoing reduction here? Cr2O7 2 minus changes to Cr3 plus. So we can write it as Cr2O7 2 minus changes to Cr3 plus. That is the reduction half reaction. What is the oxidation half reaction here? Fe2 plus changes to Fe3 plus. So the first step is over. Now we have split the two half reactions into, the equation into two half reactions. Now the next step is add the required number of electrons to each half reactions. See the reduction half reaction. There is a decrease in oxidation number by 3, isn't it? So here, if there is a decrease in oxidation number, we have to add the required number of electrons on the left hand side, isn't it? So here decrease in oxidation number by 3. Why it is by 3? Because plus 6 changes to plus 3. So there is decrease by 3. If there is decrease, add that number of electrons to left hand side. So we are going to add electrons. That is the next step. So how to add? So to this equation we have to add the number of electrons. So the equation becomes Cr2O7 2 minus plus 3 electrons giving Cr3 plus. So we are adding that 3, since there is a decrease in oxidation number. Here chromium is plus 6, it changes to plus 3. So there is a decrease by 3. Since it is a decrease in oxidation number, add that 3 electrons on the left hand side. Now see the case of oxidation half reaction. To add the required number of electrons, here there is increase in oxidation number by 1, plus 2 becomes plus 3, increase by 1. So if there is increase, add that number of electrons on the right hand side. So we are adding to the above equation. So it becomes Fe2 plus giving Fe3 plus 1 electron. So the first step is over, that is adding the required number of electrons. Now after this, the next step is, after adding the required number of electrons, the next step is balance all the atoms other than hydrogen and oxygen. In this equation, in the reduction half reaction, other than oxygen and hydrogen, we have chromium, isn't it? Now, so here I am going to balance chromium. How we can balance chromium here? In the left hand side we have 2 chromium, right hand side we have only 1 chromium. How to balance it? Yes, put 2 here. So how the above equation becomes Cr2O7 2 minus plus 3 electrons giving 2 Cr3 plus. That is the usual way to balance an equation, isn't it? Similarly, how we can balance here, which is the atom other than hydrogen and oxygen? Here iron. So here check, here we have 1 iron on left hand side, 1 iron on right hand side. So iron is already balanced, isn't it? Now after balancing all the atoms other than hydrogen and oxygen, next we have to balance oxygen. Look at this reaction to balance oxygen. How we can balance oxygen here? Check the number of oxygen atoms on the right hand side and left hand side. Here on the left hand side we have 7 oxygen. On the right hand side there is no more oxygen atoms. So left hand side 7 oxygen atoms, right hand side no oxygen, means on the right hand side there is shortage of 7 oxygen atoms, isn't it? Left hand side we have 7 oxygen atoms. On the right hand side no oxygen atoms, means on the right hand side there is shortage or deficiency of 7 oxygen. So how to balance oxygen? Where there is deficiency of oxygen, add equal number of water molecules. So how to balance oxygen is, this equation becomes Cr2O7 2 minus plus 3 electrons giving 2Cr3++, because here we have deficiency of 7 oxygen on right hand side. Deficiency of 7 oxygen on right hand side. So add 7 water molecules on right hand side. Similarly, balance oxygen on the right hand side. Is there any oxygen to balance on this equation? No, no oxygen to balance. Isn't it? Now, after balancing oxygen, the next is balance hydrogen. To balance hydrogen, we have to check the medium. Here the medium is acidic. In acidic medium, how to balance hydrogen? Count the number of hydrogen on both sides. Here Cr2O7, here on the left hand side no hydrogen atoms, but on right hand side we have 7 into 2. 14 hydrogen atoms on right hand side, but no hydrogen atoms on left hand side. So where we have deficiency of hydrogen? Yes, on left hand side we have deficiency of 14 hydrogen, isn't it? Right hand side we have 7 into 4, 14 hydrogen atoms. Left hand side no hydrogen atoms means on left hand side there is shortage of 14 hydrogen. So how to balance hydrogen in acid medium? Where there is shortage of hydrogen, add equal number of H plus ion. So on left hand side we have 14 hydrogen shortage. So the equation becomes Cr2O7 2 minus plus 3 electron plus 14 H plus giving 2Cr3 plus 7 H2. Hydrogen is balanced. So in this equation, don't forget this is our equation. Iron was already balanced, there was no oxygen to balance. Now here no hydrogen to balance in this equation. So this is our equation on the right hand side, oxidation half reaction. So after balancing hydrogen, we have one equation on the left hand side and we have one equation on right hand side. After balancing hydrogen, that is actually almost the last step. After balancing hydrogen, what we have to do is make the number of electrons same in both half reactions. Here, which is the half reaction we have? This is the half reaction on left hand side, and here we have 3 electrons. This is the half reaction that we have on right hand side, and here we have 1 electron. So here 3 electrons and there 1 electron. So how to make the electrons same in both reactions? Yes, here the right hand side equation we have to multiply with 3. So after balancing hydrogen, so here 3, to balance electrons, here there is nothing to do. This equation Fe2 plus giving Fe3 plus 1 electron, that we have to multiply with 3. So this equation becomes Fe3 Fe2 plus giving 3 Fe3 plus 3 electrons. So this is our final equation, not the overall equation. This we can write it as equation number 1 and this is our equation number 2. So equation number 1 is the reduction half reaction equation and equation number 2 is the oxidation half reaction equation. So after balancing or after making the number of electrons same in both the equation, we can write these two equations as top and bottom. So Cr2O7 2 minus plus 3 electrons plus 14 H plus giving 2 Cr3 plus 7 H2O. This is our reduction half reaction. Now we have our oxidation half reaction as 3 Fe2 plus giving 3 Fe3 plus 3 electrons. This is our oxidation half reaction. Next what we have to do is, now the number of electrons are same in both the half reactions. To get the overall equation or overall reaction, draw one line and add the two half reactions. How to add two equations? Add left hand side together and right hand side together and cancel common terms. So what we'll be getting here as Cr2O7 2 minus plus, right, left hand side, sorry, add left hand side, 3 electrons plus 14H plus 3 Fe2 plus giving right hand sides 2 Cr3 plus 7H2O plus here 3 Fe3 plus 3 electrons. This is our overall equation. Now from this equation, to get the final equation, cancel the common terms. That means 3 electrons will cancel. There is nothing else to cancel. So what we are getting finally as the overall equation will be Cr2O7 2 minus plus 14H plus 3 Fe2 plus giving 2 Cr3 plus 7H2O plus. This is our balanced overall redox reaction. So I hope it is clear to you. So first assign the oxidation state. After that split the two half reactions into two half reactions. After assigning oxidation number, when we assign the oxidation number along with increase and decrease, mark write increase by how much and decrease by how much, only that much number of electrons we have to add. So mark increase by how many electrons and decrease by how many electrons, and split the two reactions in as oxidation half reaction and reduction half reactions. Now the first step is adding electrons. If it is increase, add on right hand side. If it is decrease, add on left hand side. Then how much electrons we have to add on right and left, right side and left side depends on, it is decreased by how much and increased by how much. After adding the number of electrons, balance if there is any atoms other than hydrogen and oxygen, and if it is already balanced, here in the case of iron it was already balanced, so there is nothing else to do, right, as such. Okay, so again, so here iron was balanced, so there was nothing to do. So but we had to balance chromium. After that, after balancing all the atoms other than hydrogen and oxygen, balance oxygen first. How to balance oxygen? Count the number of oxygen on right and left. Where there is shortage of oxygen, add equal number of water. So here there was 7 oxygen on left hand side, but there was no oxygen on right hand side. So on right hand side there was shortage of 7 oxygen, so we added 7 water molecules. Then on right hand side there was no oxygen to balance, and after that we balanced the hydrogen. In this equation, on the right hand side there was 14 hydrogen, but on left hand side there was no hydrogen. So how to balance hydrogen in acid medium? Where there is shortage of hydrogen, add equal number of H plus. So here, that is why we added 14 H plus on left hand side. Then here also there was no hydrogen to balance, so we wrote the same equation as such. And after balancing hydrogen, the last step is make the number of electrons same in both half reactions. So here it was 3 number of electrons and here it was 1. So 1 and 3, how to balance? Multiply 1 with 3. So the whole equation we have to multiply with 3, so the equation will become became 3Fe2 plus, giving 3Fe3 plus 3 electrons. And mark the, after making the number of electrons same, mark the first half reaction as equation number 1 and the second one as number 2. Then write both of them as top and bottom. Then after drawing one line, add the left hand side and right hand side to get the overall equation. Cancel the common terms and we will be getting the overall equation. This is about the balancing of a redox reaction in acid medium using half reaction method. Now, another equation to balance, another unbalanced ionic equation is given. We have to balance in the acid medium. So for that, first we have to assign the oxidation number. Oxygen we know it is -2, -2 into 4 it is -8. Sum should be -1. So manganese we can take it as X, only one manganese, so X into 1 plus -2 into 4 equal to -1. So X plus -8 equal to 1. So X equal to 1. Sorry, -1 plus 8, that is equal to +7. So manganese oxidation state is +7. Iodine here it is given as -1. Here it is +2 manganese, and here iodine the free state means 0. So from this we have to write, or we have to identify the species undergoing oxidation and reduction. See the change in oxidation state of manganese. Manganese +7 to +2. +7 to +2 means there is a decrease in oxidation number. So decrease in oxidation number by 5, isn't it? So here decrease by 5, so it is a reduction. Now oxygen, on the right hand side there is no oxygen to compare. Now we have to compare only iodine. So iodine here we have -1 and here it is 0. -1 to 0 means increase by 1, isn't it? Now split these two half reactions as oxidation half reaction and reduction half reaction. Which is the oxidation half reaction here? So increase by 1 means it is oxidation. So I minus is changing to I2. Now what is the reduction half reaction here? MnO4 minus changes to Mn2 plus. So this is our reduction and oxidation half reactions. Now here we know that it is -1, it is 0. Here increase by 1, isn't it? So here it is +7, +7 to +2 means decrease by 5. So the first step is here when we assess the oxidation state, here there is a twist. There is a small difference here. What is the oxidation state of iodine? It is -1, and here how many iodine? 1 iodine. So -1 into 1, -1. Here it is 0, 0 into 2, isn't it? So here we have 2 iodine atoms. So when we assign the oxidation state, we have to assign the oxidation state of equal number of atoms. So here we are multiplying 0 into 2, isn't it? So 0 is the oxidation state of free iodine. So 0 into 2 we are writing. So here also we have to write it as 2. Oxidation state we have to take we have to consider the case of same number of atoms. So here if it is 2, here also we have to multiply with 2. So minus 2, 0. So here what happens? Here there is minus 2 to 0. So here actually there is an increase in oxidation number by how much? Minus 2, minus 1, 0. So increase by 2. And here, so if there is an increase by 2, how to balance? The first step is add electrons. How to add electrons? There is an increase by 2. So if there is increase, add on the right hand side. So it will become I minus giving I2 plus 2 electrons. And here, how we can balance? Here there is a decrease by 5 electrons. So if there is decrease, add on left hand side. So this equation becomes MnO4 minus plus 5 electrons giving Mn2 plus. Now after adding the number of electrons, we have to balance all the atoms other than hydrogen and oxygen. So here other than hydrogen and oxygen we have iodine. So how to balance iodine here? Here we have 1 iodine, here we have 2 iodine. So it will become 2I minus giving I2 plus 2 electrons. So here other than hydrogen and oxygen we have manganese. So how to balance manganese here? 1 manganese on both sides. So manganese already balanced. Now after balancing all the atoms other than hydrogen and oxygen, we have to balance oxygen. But here there is no oxygen to balance. So this equation will remain as such. But here we have oxygen to balance. See, on the left hand side we have 4 oxygen, on the right hand side there is no oxygen. That means on the right hand side there is deficiency of 4 oxygen atoms. So how to balance oxygen? Right hand side there is shortage of 4 oxygen, means on the right hand side add 4 water molecules plus 5 electrons giving Mn2 plus 4 water. So where there is deficiency of oxygen, add equal number of water molecules. Now after balancing oxygen, the next step is to balance hydrogen. How to balance hydrogen? So here in this equation there is no hydrogen to balance. But here we have, see, on the left hand side no hydrogen, on the right hand side we have 4 into 2, 8 hydrogen. So to balance hydrogen, see the medium, here the reaction is taking place in the acid medium. So where there is shortage of hydrogen, add equal number of H plus. So right hand side we have 8 hydrogen, left hand side no hydrogen. So left hand side add 8 H plus. So the equation becomes MnO4 minus plus 5 electrons plus 4 into 2, 8 hydrogen deficient means 8 H plus giving Mn2 plus 4 H2. After balancing hydrogen, we have to see the number of electrons in both half reactions. In the first half reaction, this is our equation, 2 electrons, and here we have 2 electrons and here we have 5 electrons in each half reaction. So how to balance 2 and 5? Multiply 2 with 5 and 5 with 2. So how we can write it as 2I minus giving I2 plus 2 electrons multiply with 5, and this equation MnO4 minus plus 5 electrons plus 8H plus giving Mn2 plus 4H2O, that we have to multiply with 2. Now after multiplying, the two half reactions become 5 into 2, 10I minus giving 5I2 plus 10 electron. This is our first half reaction. Now here 2MnO4 minus 2 we have to multiply here plus 10 electrons plus 2 into 8, 16H plus giving 2Mn2 plus 8H2O. This is our second half reaction. After making the number of electrons same in both half reactions, mark them as 1 and 2. Now write these 1 and 2 reactions as top and bottom. I minus giving 5I2 plus 10 electron. This is our reduction half reaction. Oxidation half reaction is 2MnO4 minus plus 10 electron plus 16H plus giving 2Mn2 plus 8H2O. That is our oxidation half reaction. To get the overall reaction, draw one line and add right hand side and left hand side. And we get 10I minus plus, add left hand side together, 2MnO4 minus plus 10 electron plus 16H plus giving, add right hand side, 5I2 plus 10 electron plus 2Mn2 plus 8H2O. Now cancel the common terms. 10 electrons will cancel. Is there anything else to cancel? There is nothing else to cancel. So the final equation will be 10I minus plus 2MnO4 minus plus 16H plus giving 5I2 plus 2Mn2 plus 8H2O. So this is our overall balanced redox reaction. So this is the way to balance a redox reaction in acid medium.